Hello everyone, Mr. McDonald here. I just want to take a moment to talk you through how home learning is going to be in the next 3 weeks between now and the Easter holidays. Teachers have been challenged to provide live classroom lessons to reduce numbers of pupils, provide online materials for those learning from home, provide availability for working in the hub to make sure the children of key workers are supported, and to cover any staff illnesses that may occur between now and the Easter holidays. That's a big task, and the only way I could think of effectively covering all those duties was to create these online YouTube lessons. These lessons will talk you through what you need to know to complete the lesson tasks and hopefully provide you with about 2 hours of working materials that you can cover to make sure that you continue to develop through your maths. I will be hopefully providing online chat to support and guide you through these materials as well. But as I say, there's lots of different things that I could be pulled away to provide support with. So that may not always happen. I'm hoping that it will, and I'm hoping that our lessons will progress pretty much as they have been before. But if I am pulled away for any reason, you still have these online lessons that you can work through and make sure that you're progressing in your maths, because that is the most important thing during this period. Thanks very much for your patience, everybody. And without further ado, let's get into today's lesson. Okay, so for today's learning intentions, we are going to review the expressions and formula non-calculator questions in National 5 Maths exams, and we're going to practice exam skills and good exam practices. I can complete expressions and formula questions that have appeared in previous past papers is one of the things I hope you should be able to say by the end of this lesson, and I know how to study effectively and have resources to do so is the other. Okay, so first of all, I want to talk about how to revise maths. This idea of a continuous improvement cycle is something that I think is really important to bear in mind when you're revising for your final maths exam. Okay, you should be planning, doing, checking, and acting, and that doesn't finish after one rotation. Okay, you should be continually trying to refine your skills and continually adapting your plan to what you need to be able to do. All right, there's a few different things that you can use to do that. You've got checklists in Class Notebook that will allow you to think about the different topics involved in National 5 Maths. Right, that's the planning stage. Right, go through your checklists, check what you can do and what you can't do. If it doesn't ring any bells, make sure that you put it on your list of things to improve. If it does ring bells and you know you are confident with it, then make sure that you don't put it on your list of things to improve. As long as you're at that peak point, then that's absolutely fine. The next step is to do. So find practice questions for those topics that you're not sure about. Practice past papers for the whole course overview. Okay, make sure that you get your work marked. That's the checking part of this cycle. Make sure you get your work marked either by me or by yourself if you've got access to a mark scheme. And come along to supported studies. I'm going to talk to you a little bit about supported studies a little bit later in this lesson, and hopefully for some people it will be live in person as well. But supported study is going to be a thing that I run online for the next few weeks. And then hopefully after the Easter holidays, we can then think about running supported study in person as well. But make sure you get your mark work to get guidance and support in supported study. And then the last little step is to act, repeat or move on, okay? Either you need to repeat it because you haven't quite got it the first time around, and that's okay. That happens to everyone. The amount of times I have relearned a topic because I just didn't quite get my head around it the first time. That's totally alright, and it doesn't mean that you're a bad mathematician or that you're bad at maths. It just means that you need that extra little bit of reinforcement, that's all. Or you can move on, find another thing to tackle, and make sure you're refining that. Okay, hopefully by the end of repeating this a good few times, this cycle, you'll start to feel a little bit more confident about taking on things like whole past papers. You'll start to feel a bit more confident about tackling exam questions quickly. And that's the kind of thing that you need to do in order to improve yourself and become one of the top Nat 5 pupils in Forestry. Okay, remember that bottom sentence as well. Practice makes progress. It doesn't make perfect. Absolutely no one is perfect at maths. Okay, you may be perfect at Nat 5 level, but there's always something that you can learn. Same as I could be perfect at National 5 level, but there's always something that I could learn as well. Okay, nobody ever learns everything in maths. Okay, so today we're going to look at expressions and formulae. Some of the topics that are outlined on the board here are surds, indices, volumes, circles, algebraic fractions, and scientific notation. There's also a little bit of work with algebra as well, which is continued on in the next topic, relationships. But we're going to do a bit of algebra today too. Alright, like I said, we're going to focus in on non-calculator skills today. Alright, so things that don't require a calculator, things that you should be working with a pen and paper to try and figure out. That's all you need for today is a pen and paper. Right, so the first thing we're going to look at is surds. In specific, we're going to look at surd calculations to start with. Okay, and I've got an example of a surd calculation from an exam, past paper 2014, paper 1, question 8, but there are loads more. If you go into national5maths.co.uk and have a look at the surds exam questions by topic section, and then you'll find loads and loads of these. But there's an example just up at the top right there. What you need to do when you are simplifying a surd calculation is first of all identify which surds simplify and which surds don't. Okay, in this case, root 5 is fully simplified already. There's no square number other than 1 that divides into the number 5. Whereas the two surds on the outside here, root 45 and root 80, both have square numbers that divide into them. So we can simplify these further. Alright, I know because of this root 5 being fully simplified in the middle here, that all of my surd calculations are going to end in root 5. Okay, so I just need to think about how many times does 5 go into 80? I know it's going to end in root 5, but how many times does 5 go into 80? Well, 80 is 16 times 5. And we've lucked out there because 16 is a square number, so I can fully simplify this in the next step of our calculation. Alright, the middle root 5 just stays as it is. And root 45, how many times does 5 go into 45? Again, I know that second part has to be a 5. So really, as long as you can divide by 5, you'll be fine for this next step. It is 9 times 5. Okay, so root 80 is turned into 16 root 5. The normal root 5 on its own has stayed the same, and the 45 has turned into root 9 root 5. Remember that you can represent a root by the product or the multiplication of two other roots that times together to make that number. Okay, the next step is to look at these roots out the front that are square numbers and turn them into whole numbers. Because I know that the square root of 16 is 4. So instead of writing root 16 root 5, I'm going to write 4 root 5. Okay, the root 5 in the middle of my calculation has not changed since the very beginning. It's not going to change again in this line. Then I know the square root of 9 is 3, so I'm going to write down 3 root 5. The very last step of this calculation is to add up the numbers that are multiplying our surd root 5s. Okay, that is the number 4, the invisible number 1 that appears in front of a root on its own, and the minus 3. Remember to take that sign into account as well. Okay, I might even just put in my working the number 1 here. Okay, it's not very good form to put the number 1 in there, but it keeps us kind of Keeps us aware of that 1 being there. Okay, and the last part of this is to add together our front numbers, like I said. So we're going to take 4 and add on 1, which makes 5. And then we're going to take away the 3 on the end, and that makes 2 left over. Okay, because all of these calculations were to do with root 5s, we've got our root 5 on the end of our answer as well. Okay, and that is how to simplify a surd calculation. If you need more time with this, pause the video. Make sure that you copy down this in full if you're not sure about it. If you are totally certain with it, move on to the examples on the next page. Okay? If you have any questions, hopefully I'll be in the chat to answer your questions too. Okay, here are 6 examples of surd calculations. Pause the video here, complete these 6 calculations. I'll be giving you the answers in just a couple of seconds. So make sure that if you are not finished with these, that you pause the video now. Okay, the answers to your questions are there on the board in red. The answers are underneath the calculation. So the first one is 6 root 7, the second one is 2 root 3, the third one is 9 root 2, the fourth one is 12 root 10, the fifth one is 5 root 2, and the last one is just root 5. Or if you put 1 root 5, I'll give you it, but it's not particularly good form. Okay, make sure that if you've got just 1 root 5, you just put the symbol for root 5 down. Okay, the next thing we're going to look at with surds is how to rationalize a fraction. Alright, again, I've got a past paper example in the top right hand corner, past paper 2019, paper 1, question 12. Alright, what we're being asked to do is express root 2 over root 40 as a fraction with a rational denominator and give your answer in its simplest form. Okay, so what I'm going to do, first of all, is I'm going to write out that fraction again, just so I've got that in my solution. So root 2 over root 40. Right, the first thing I'm going to do is I'm going to multiply both sides of this fraction. To keep it equivalent, you have to times both sides of the fraction by the surd that's on the bottom of the fraction. So I'm multiplying by root 40 on the bottom, and then also on the top of the fraction to keep it an equivalent fraction and not change the size. Okay, so remember in the previous exercise when I said if you multiply two roots together, they make just the multiple of that root, of those roots in a square root sign. Okay, so 2 times 40 makes the number 80. So I got root 80 on the top of my fraction here. Okay, I could also do root 40 times root 40 is equal to root 1600, because 40 times 40 is 1600. But actually what you should know is if you multiply a root by itself, that's the same as squaring a root. Okay, and a square root sign and a squared sign cancel each other out. So what I'm left with here is just the number 40, without a square root sign and without a squared sign. Those two things cancel each other out. Okay, the next thing I have to do with my calculation is check the top half of this fraction. Does this have any square number that can divide into it as a factor of 80? And in this case, yes, there is a square number that divides into 80. Okay, I can rewrite this fraction as root 16 on the top times root 5. 16 times 5, both times together to make 80, over 40. Okay, your first instinct might have been to divide by 4 because that's a square number as well. But actually 16 is the biggest square number that divides into both. Okay, the next thing I need to do is to make sure that this root 16 is represented as a whole number. I'm going to move this up to the top of the page. Normally we would just work vertically, but make sure, just to make sure that there's space, I'm going to go back up to the top of the page here. Root 16 becomes whole number 4. Root 5 is multiplying that whole number 4, and it's all over 40 still. I have one more thing I have to check for, which is I need to check that if there is a common factor between the multiplier of my surd and the denominator of my fraction, then I need to take out a common factor. In this case, both of these numbers that I've highlighted divide by 4. So I'm going to divide by 4 on the top. I'm going to divide by 4 on the bottom. Remember, whatever you do on the top of a fraction, you must do the same on the bottom of the fraction. Otherwise, your fraction becomes imbalanced. It's no longer equivalent. Okay, in this case, I've got 1 root 5 on the top, which I'm just going to write as a square root 5. And then I've got 10 groups of 4 on the bottom. And again, that's my final answer. That is how you rationalize a fraction. Okay, just to recap that one more time. I multiplied the numerator and the denominator of the fraction by the root that was on the bottom of the fraction. Then what I did was I checked to see if whatever was on the top of the fraction could be simplified. In this case, root 80 could be simplified because it divides by a square number, divides by 16. Then what I looked to do was take out any square roots that I could. So root 16 turned into 4. And then finally I checked for a common factor on the top and bottom of my fraction to see if the fraction simplified. It did, because I was able to divide by 4 on the top and bottom, and I got my final answer of root 5 over 10. One thing that we need to be very careful of is that we're not taking a common factor from our surd number and the denominator of our fraction. Okay, because one is a whole number and one is a surd, you can't do that. Okay, whereas the whole number on the left hand side, the multiplier of 4, does have a common factor with 40, and that works perfectly fine. Okay, again, if you need this board for any length of time, just pause the video, and then I'm going to move on to some questions in just a second. Okay, so here are 6 examples of fractions that I would like you to rationalize. Remember, that means no surds can exist on the bottom of the fraction. Okay, pause the video here. I'll give you the answers in just another couple of seconds. Okay, and here we have the answers. The first one, 2 root 10 over 5. The second one, 9 root 2. The third one, root 10 over 4. The fourth one, root 2. The fifth one, root 15 over 15. And the sixth one, root 5 over 5. Remember that you cannot take the common factor between a surd number and just a whole number denominator. So root 15 over 15 has to stay that way. You can't take out a common factor of 15 there. Same with the last one, root 5 over 5, you can't take out a common factor. Okay, the next type of question that we're going to look at is index calculations. There are a few different rules of indices that you need to remember. The first is that if you take an index, sorry, if you take a base and raise it to an index of, let's say, m, and then you multiply that with the same base to the power of n, you are going to get the sum of those two powers as your new power. Okay, so the two numbers there, m and n, whatever they may be, will have to be added together to get your final answer there. Okay, the second rule is if you're dividing, let's say, b to the power of m by b to the power of n. Okay, so the same base again. You're going to get b to the power of m minus n, one power on top, take away the power on the bottom as your new power. Finally, the last thing that we need to remember is if we've got a different base to the power of m, then raised to the power of n, you are going to get the new power being the multiple of both of those two things, or the product of those two things, m multiplied by n. Okay, in each of these examples we have to apply one or more of these different rules. Okay, so for this first one here, what I'm going to do first of all is I'm going to perform the calculation on the top half of this fraction. Alright, so 5x to the power of 5 times 8x to the power of 9. I'm going to leave the bottom half of the fraction alone for now. So I'll just rewrite that. 20x to the power of 8. Alright, that will come into our calculation a little later on. Okay, so to multiply these two indices on the top of this fraction, we're going to multiply the front numbers first of all. Okay, because they're just whole numbers, they're not indices. They don't follow any rules of indices. We're just going to multiply them like we would multiply a 5 and an 8 in any scenario. Okay, we're going to put our base down, which is x, and then we're going to apply the first rule of indices that I've listed at the right hand side here. When we're multiplying two bases that are the same, we're going to have to add together the power numbers. Okay, so x to the power of 5 and x to the power of 9 combine. We're going to do 5 plus 9 to get our new power number, which is 14. Okay, so this 14 here has come together from adding 9 and 5. The next step we're going to take is the division. Oops. We're going to divide 40x to the power of 14 by 20x to the power of 8. Okay, so again, the whole numbers, 40 and 20, just act like they normally would. Alright, 40 divided by 20 leaves you with 2. Then we've got the same base raised to powers. We're going to do 14, take away 8, just like the second rule in our listed rules of indices tells us. Okay, 14 take away 8 is 6, so I'm left with x to the power of 6. My final answer is x to the power 2x to the power 6. Okay, that 6 there comes from starting with a 14 and taking away an 8. That 14 is being used from the previous calculation, which is 5 add 9. That gives you the 14. Then 14 take away 8 gives you the power 6 in your final answer. Same as with the whole numbers, we're multiplying 5 and 8 to give us 40. And that 40 is being used in the calculation and being divided by 20 to give us the 2 at the front. Okay, one more quick calculation here. This is the third rule that I've listed in our index rules here. Okay, I'm squaring everything in the bracket. So the front number, 2/5, just acts like it would normally act if I was squaring it. Okay, I'm going to square the number 2, which is 4. I'm going to square the number 5, which is 25. I'm going to write down our base, which is W, and then the third rule of indices tells me that if I'm raising a power to another power, I'm going to multiply them together to get my final power of my index. Okay, so 5 times 2 gives me 10 on the end. Okay, so the reason I got this number 4 here was because I'm squaring the number 2. So I'm doing 2 times 2 is 4. The reason I got the number 25 in my final answer is because I've squared that number 5 on the bottom of the fraction. That now makes 25. And then finally, the reason why I got the number 10 in my final answer is because I have done 5 times 2 as per my rule of indices, or my rules of indices, to get my final power. Okay, if you need longer with this board, pause it now. If not, I'm going to go on to a few examples in just a second. And here you are. Here's 6 calculations to do with indices. All right, 1 through 3 are all kind of like the first one that I did on the boards, and then 4 through 6 are kind of like the second one that I did just a second ago. Okay, I'll zoom in a little bit on those so you can see them a bit better. Pause the video here. I'll give the answers over in just a couple seconds. Make sure you're not cheating. Make sure you try these genuinely first before you check your answers. Okay, and here are your answers for those 6 questions. Number 1, you should have 2x to the power of 6. Number 2, 4x to the power of 9. Number 3, 8x to the power of 9. Number 4, 1/8 x to the power of 12. Number 5, 4/25 x to the power of 14. And the last one, number 6, 1/100,000th of x to the power of 35. Okay, Nat 5s. The next topic that we're going to look at is expansion and simplification. This is an algebra topic, and the example that we've got at the top of the board there is past paper 2018, paper 1, question 2. Again, another paper 1 topic. You're not supposed to use a calculator with this. You've got to just use your mental arithmetic. Okay, so for this first example, we've got 2 different types of expansion. We've got double bracket expansion at the beginning here, and we've got a single bracket expansion at the end. So for my double bracket expansion, I'm doing first, outer, inner, last, FOIL. Alright, first gives me 3x times x. That leaves me with 3x squared. Outer, that's going to be the 3x times the minus 1. That'll give me minus 3x. The inner, that gives you plus 1 times x, which is just plus x. Remember, if you feel like putting down 1x, we tend not to put 1 as a multiplier because 1 multiplied by anything is just itself. So we just put down x. And then the final little bit, plus 1 times minus 1 gives you minus 1. Okay, so that is first, outer, inner, last, performed on 2 sets of brackets to expand those brackets out. The next part of this is going to be a single bracket expansion, and because I'm multiplying through by plus 2, I'm going to put my plus sign in here, and plus 2 times x squared gives me 2x squared. Then finally, plus 2 times minus 5 gives me negative 10. Right, just to make sure that I've fully expanded and simplified this equation properly, I'm going to have a look through and see if there's anything that can be collected here. Alright, so in yellow I'm highlighting the x squared terms. So I've got 3x squared at the start of this equation, this expression, and I've got plus 2x squared towards the end. Okay, they can be collected together. I also have minus 3x and plus x. Those two things can also be collected together. And finally, I've got minus 1 unit and minus 10 units. Again, those two things can be collected together. So to finish this expression off, 3x squareds plus on 2x squareds, that gives me 5x squareds. Minus 3x's plus on an x. Okay, if you're at minus 3 and you add one thing, then you're going to be at minus 2. So minus 2x's in the middle there. And then our final term, our units term, is going to be minus 1. Take away another 10. So we're at minus 1 and we have to go down the number line 10 places. We're going to end up at minus 11. Alright, so my final answer here is 5x squared minus 2x minus 11. In the second example here, I've got a double bracket multiplied through a triple bracket. Okay, so again, I'm going to expand and simplify this expression. If you need a little bit more time on the first expression, then make sure that you pause the video here, but I'm going to move on to the next one. Okay, so for this, we need to use kind of an extended version of first out or inner last. So we're going to multiply our first term in our double bracket by each of the terms in the triple bracket. So it's first, middle, outer, which is a little bit confusing. X times x squared gives you x cubed. X times 2x gives you plus 2x squared. And x times minus 9, remember to include that negative sign, gives you negative 9x. Then the next part of this, I'm going to take the second term in my double bracket and multiply it through each term in the triple bracket. So again, we've got inner, middle, and last in our FOIL. So plus 4 times x squared is plus 4x squared. Plus 4 times plus 2x gives you plus 8x. And finally, plus 4 times minus 9 gives you negative 36. Okay, again with my highlighter, I'm going to go through and look for things that can be collected, like this 2x squared here and this plus 4x squared here. Those two sets of terms can be collected, as well as this negative 9x here and this plus 8x here. The x cubed term, there isn't any other x cubed term, so that stays as is in our solution. And same with the minus 36 units. There's no other unit terms, so we're going to finish off with just minus 36 on the end. So x cubed stays as it is. The x squared terms, I've got plus 2x squareds and plus 4x squareds. So that gives me plus 6x squareds. For my x terms, I've got minus 9x plus 8x. That gives me minus 1x. Remember, if you've got a multiplier of 1, you just leave it out because 1 times anything is just itself. And then at the very end here, we've got minus 36 units. Just like I said, it doesn't have anything to collect with, so it just gets put on the end of your solution. Okay, and that's our final answer for this question here. Again, if you need the board any longer, make sure you press pause here, but I'm going to go into the questions that you need to complete. Okay, so here are 6 questions that you need to complete, all to do with expanding and simplifying. Make sure that not only you expand, but you simplify by collecting terms at the end. Pause here, give yourself a bit of time to do this exercise, and then when you're ready, unpause and I'll give you the answers. Okay, the answers to these questions are, for number 1, you should have negative 1x squared plus 7x plus 22. For number 2, you should have negative 4x squared minus 12x plus 40. For number 3, you should have negative 2x squared plus 5x minus 20. You should have, for number 4, x cubed plus x squared minus 13x plus 35. For number 5, you should have x cubed plus 3x squared minus 28x plus 30. And then finally, for number 6, you should have x to the power of 4 minus x to the power of 3 plus x squared minus 3x minus 6. Okay, so the next type of question that we're going to look at is arcs and sectors. We're going to focus on just arcs and sectors without the use of a calculator just now. So you should take note of that last little sentence in this question, which is take pi equal to 3.14. That is a big giveaway that you are doing a non-calculator question and that you are asked to work out this as part of your mental calculations, okay, written on paper. We've got here a question about finding the length of the major arc AB. So here we have to use the arc length formula. So the arc length formula, remember, is AL is equal to the angle at the center of the sector divided by 360 multiplied by pi d. Pi d, remember, is the circumference formula. So if we're looking for arc length, which is just part of the circumference, we have to incorporate that in our calculation. This is one of those things that is not given to you in a formula sheet, so you need to bear this in mind and commit this to memory before you set any final assessment. Okay, the second step of this calculation is to substitute in the details from the diagram. So I'm going to substitute in 240. I'm going to divide it by 360. I'm going to times that by pi, which is 3.14 in this question, or that's what we're saying pi is going to be. And then I'm going to multiply by the diameter, which in this case we've got a radius of 30, so our diameter is 60. Be very careful. If your formula calls for diameter, you've only been given radius, you have to multiply it by 2. Conversely, if you've been given diameter and you need radius for your formula, then you need to halve it. Okay, the next step in this calculation is to look at this fraction in front of our pi. What we're going to do is we're going to simplify this as fully as we can to make it easier to calculate what we're doing next. Okay, so I'm going to divide by 120 on the top and bottom here, and I'm going to be left with 2/3 as a fraction. I'm multiplying that by 3.14, and I'm multiplying that by 60. The easiest thing to do next, and the thing that I would always advise to do, is look at the fraction and look at the last multiplier in your formula. Okay? You can find that fraction of that amount. It's much easier than finding 2/3 of 3.14. So I would make a whole number by finding 2/3 of 60 first of all. So I'm going to do 60 divided by 3, which is 20, and then 20 times 2 leaves us with 3.14 times by 40. That's 2/3 of 60. Finally, we want to put in our mental calculation skills here. So I'm going to do 3.14 times 10 in my head, first of all, which is 31.4. Okay, and after timesing by 10, to get times by 40, I need to times it by another 4. Okay, set up a simple calculation. 4 times 4 gives you 16. So I have to carry 1 onto the next column. 4 times 1 is 4, add 1 is 5. I don't have to carry anything onto the next column this time. And then 4 times 3 is 12. So my final answer here is that my arc length, if I'm using 3.14 instead of the pi button on my calculator, is going to be 125.6 centimeters. Okay, so that is one half of the non-calculator questions that you could be asked to do as part of the arcs and sectors topic. The other is if you were asked to find a sector area. Just to remind you before you go into a few questions that the sector area formula is very, very similar to the arc length formula. The sector area formula is SA for sector area is equal to angle over 360, just like before. But instead of multiplying by pi d, we're multiplying by the circle area formula, which is pi r squared. That is your only difference. Okay? If you are calculating a sector area, I still advise you take exactly the same steps. So step number 1, substitute in your numbers. Step number 2, simplify the fraction in front of your calculation. Step number 3, find that fraction of the last number. That way it's easier to multiply by pi. Okay, final section is, or the final step is to multiply 3.14 by whatever number you're left with. And that is where your mental arithmetic comes in a little bit. I'm expecting to see chimney sums. I'm expecting to see you're multiplying by 10 or 100 or 1,000, depending on what your final number is as well. Okay, make it easy for yourself. Right, in this case, you've got 4 examples to try. Pause the screen here. I'll give you the answers to these 4 questions in just a couple of seconds. Okay, here are your circle, arc, and sector answers. The first one, the sector area was 37.68 centimeters squared. The second one, your arc length is 15.7 centimeters. In your third one, the sector area was 4.71 meters squared. And then in your last one, your arc length was 314 millimeters. Note that when you're calculating sector area, your answers have to end in units squared. That is often an area in which a National 5 candidate could lose a mark because you need to show your knowledge of area moving from normal units of measurement to squared units of measurement. Okay, for the arc lengths, you just need to put centimeters, millimeters, meters, whatever you're measuring in on the end of your answer because you're measuring the curved line distance. Okay, moving on to our last topic for today's lesson. This is algebraic fractions. In these, we are going to look at a few different methods for solving algebraic fractions questions. That is adding and subtracting algebraic fractions and multiplying and dividing algebraic fractions. I've linked them together because the methods are very, very similar for adding and subtracting, and the methods are very, very similar for multiplying and dividing. Okay. All right, so I'm moving in on this first question first of all. So the way to approach an algebraic fraction in terms of adding and subtracting, what you need to do is you need to use the cross and smile technique. Okay, the smile will tell you what the answer on the bottom of the fraction is, whereas the cross will tell you the answer on the top half of the fraction. Okay, so for this example here, on the bottom of the fraction, I'm going to draw my fraction line in here. We're going to get x minus 2 multiplied by x plus 5. Okay, I know that they don't start in the question in brackets, but because I'm multiplying everything in this bracket here by everything in this bracket, sorry, everything on the bottom of this fraction here by everything on the bottom of the second fraction, I need to make sure that those things are grouped. Okay, so my x minus 2 gets grouped because it was in the first fraction, so I put brackets around it, and then x plus 5 was in the second fraction, so it gets brackets around it as well. Okay, the second part of this is the top half of the fraction. I'm going to multiply the 4 on the top left of the fraction by the x plus 5 on the bottom right of the fraction. This is the first half of our KISS. Okay, because this is a takeaway sum, I've kind of obstructed it here. I'm going to just move my KISS up a little bit. This is a takeaway sum, so I'm going to put a takeaway in between my top half elements here. And then bring the KISS down again. This shows you that I had to multiply the 3 on the top right of the fraction by the x minus 2 on the bottom left of the fraction. Okay, so 3 multiplied by x minus 2. If you have a wee bit of algebra kind of running off the edge of the fraction there, just extend your fraction line a bit. Make sure that everything is incorporated just so it doesn't look sloppy and no one can pick you up for any elements not being on the fraction. Okay, the next thing I need to do is I need to multiply out these brackets on the top half of the fraction. So I'm going to get 4x and then 4 times 5 is plus 20. We're then multiplying through our next bracket by minus 3. Okay, that negative sign has to be taken into account as well. Okay, so the next two terms are negative 3 times x, which is negative 3x, and negative 3 times negative 2, which gives us plus 6. Be careful with those double negatives. The bottom half of the fraction, the denominator, stays exactly the same. I've got x minus 2 in brackets, x plus 5 in brackets. If you like an extra challenge, by all means expand these out. But there's no extra points in a final assessment for that, so it's not necessary to do. Finishing this off, I'm just looking for things in common. So this 4x here and this minus 3x here are in common, same as the plus 20 that is here. Oops, the plus 20 that's here, if my highlighter will help me, and the plus 6 that's here are in common as well. So we need to combine those for our final answer. So 4x minus 3x leaves me with just 1x on the top of my final answer. Okay, and then 20 plus on 6 gives me plus 26. Then on the bottom half of the fraction, just like before, I'm going to write x minus 2 and x plus 5. Okay, and that is the fraction in its simplest form. I know it doesn't look very simple, but we have all the x's combined, all the numbers combined on the numerator, and our two multipliers are together on our denominator. That's all we can do. Okay, for the second example, I'm going to do a division. I should say, first of all, the only difference between subtraction in algebraic fractions and an addition in algebraic fractions is this sign here. Where we had a negative there, if it was an add, you'd have a positive in that position. Okay, that is because there would be a plus in the middle, and you're going to do top left times bottom right, add top right times bottom left. Okay, so the only change with the plus is that would be a plus sign instead of a minus, and then you'd be multiplying through your second bracket by a positive number instead of a negative number. Okay, in the second example here, I'm going to do a division. The way that we do division with algebraic fractions, or any fraction for that matter, is we are going to do keep, i.e. keep the first fraction the same, change the division sign to multiplication, and flip, which is flip the second fraction over, so the denominator becomes the new numerator, and the numerator becomes the new denominator. Don't get stressed out about things like this. Okay, this just tells you that n in our fraction here cannot be -2 and cannot be 2. The reason for that is because if n was one of those two values, you would get a 0 value on the bottom of your fraction, and you know you can't divide by 0, so that would kind of invalidate this calculation. So n does not equal -2 and n does not equal 2 doesn't add any extra information to what you are doing. Okay, it just tells you which values you can't do this sum for. I.e., my advice is just ignore it. Alright, so we're going to do keep, change, flip. So I'm going to keep that first fraction, n divided by n squared minus 4. Okay, I'm going to change the division to a multiplication. And then I'm going to flip the second fraction over, so I've got n minus 2 on the top, and I have the number 3 on the bottom. Okay, when you're multiplying together two fractions, all you need to do is multiply the top half of the first fraction by the top half of the second fraction, and multiply the bottom half of the first fraction by the bottom half of the second fraction. Okay, so I'm doing n times by n minus 2. And I'm doing 3 times by n squared minus 4. What's important is if you look for some common, you'll notice on the bottom of this fraction we have a difference of squares. That's something that you have learned during your factorization topic. So what I'm going to do is I'm going to rewrite the top half of this fraction, but I'm going to fully simplify. Oh wow, why am I using an x? Let's try that again. Again, always check your working back just to see if there's any silly little mistakes made like that. I'm continually reviewing my answer just to make sure that it's not silly or not lacking any details that I need. Okay, so n squared minus 4 is a difference of two square numbers. So what I'm going to do is I'm going to factorize that as n plus 2 bracket n minus 2. What we can then spot is that we've got an n minus 2 on the bottom of the fraction, and we've got an n minus 2 on the top of the fraction. So what we can do is we can take out that common factor. Our final answer is going to be n over 3 lots of n plus 2. Okay, again, if some of your algebra spills over, just make sure you extend your fraction line. Don't get caught with any sloppy notation. Okay, and that's our final answer there. Obviously, if we're doing a multiplication, you don't have to do the keep, change, flip at the start. You just multiply the top half of each fraction and the bottom half of each fraction before you go on to simplify. Okay, if you are doing a division, keep, change, flip is your strategy, and then you go straight into doing a multiplication instead. Okay, I'm going to give you a few examples of this to try out, and then I'll give you the answers after that. Make sure you pause on this screen. I'm going to give you a slightly different view so you can see all of the questions. Make sure you pause on this screen until you're ready to take the answers, and I'll be with you in just a second for those answers. Okay, and here we have your answers. For question 1, you should have 7x minus 14 over x plus 3 times x minus 4. For number 2, x minus 11 over x plus 1 times x minus 2. Number 3 is 10x squared over x minus 10 times x minus 3. For number 4, 8x minus 40 over 3x plus 18. Number 5 is 5x minus 17 over x minus 5 times x minus 3. Number 6, negative x plus 2 over x plus 4, x plus 5. Number 7, 3m cubed over m plus 8 times m minus 2. And the last one, number 8, 2a squared plus 14a over 5a minus 15. Okay, we have come to the end of our lesson. What I want to make sure that you do before you kind of pat yourself on the back and say well done for this lesson is make sure that you go to the checklist that is on your OneNote and make sure you give yourself a green light on the sections that you felt comfortable with today. If there's anything that you struggled with or you think you need a little bit more work in, make sure you give yourself an amber, and if there's anything you felt completely lost with, and hopefully there wasn't, but if there was anything, then make sure you give yourself a red light and endeavour to come to support study with a few examples in mind for that, and I'll make sure I support you through that. If there's anything else I can do, you know that my email address is at the top of chat. Make sure you let me know, and until next time, thank you very much for working hard, and I'll see you again in another video very soon.